Hello everyone, good afternoon, good morning, good evening, depending on where you are and when you will be listening to this. I wanted to do a quick introduction. My name is Aaron Delp and I'm Director of Solutions at SolidFire, and wanted to take some time today to really kind of walk you through three big questions that I want to answer coming out of this webinar today. And number one, why was SolidFire created? I want to really kick off with that question primarily because the origin story, if you will, of SolidFire is very different, and also because of that differentiates us as both a product and a solution in the market. And because of that, and as part of the recent Netapp acquisition, where does SolidFire fit in a Netapp portfolio will be the second question. And lastly, we're going to talk about a couple of the key features. Not necessarily go deep on all the features today, but wanted to just give you an introduction of specifically around what does it mean to be a scale-out, specifically a shared nothing scale-out architecture. What does it mean to offer guaranteed performance, and why would you want to offer that? And lastly, if we're going to be combining a lot of workloads and doing a workload consolidation initiative, how do you manage something like that at scale? And we'll be talking about APIs and automation a little bit. Before I do that, though, I do have one or two polls I want to go through very quickly, to be honest with you. But I wanted to do them so that we can gather some information that really would help me specifically talk to y'all. I want to make sure that this message is as relevant as it can be to the audience that did take the time out today. So if you don't mind, please go ahead and the poll should be in front of you. Go ahead and look at that and then submit the appropriate results. I'm going to leave this one open and then for, let's say another 10, 15 seconds or so. And then I'm going to move on to the next one. Like I said, I want to go through these quickly so we can get to the meat of the content. All right, thank you very much for that. Just moving on to the next one now. And really this one is the idea of one or more, if you will, workload scenarios. Because at the end of the day, SolidFire is really about consolidating workloads. So this isn't just necessarily about islands of storage. It is really about what are the different workloads that you are potentially interested in consolidating down to a potential storage array in the future. And with that, thank you very much for this participation. I'll move on to the next one. It's very important for us with protocols. As part of the Netapp portfolio now, certainly which protocols you're interested in are very important and can help certainly shape the future of both this solution and what kind of fit it can be in your environment. So I'm going to leave this one open just a few more seconds. All right, fantastic. Thank you, everyone. And last one, I promise. What is, not just what are the workloads, but at the end of the day, why are we doing it? What are the business drivers? What are the change that needs to happen within your organizations that are really maybe potentially causing you pain or that areas for improvement and optimization in the future as well. And I'll leave this for just a couple more seconds. Fantastic, everyone. Thank you very much for your time. Now, why was SolidFire created? It's actually an interesting backstory, and it's actually very relevant to why SolidFire fits the way it does and why SolidFire was built the way it was. Dave Wright, the CEO and founder of the company and now GM of the business unit within SolidFire, within Netapp, had a problem. He had a product. His previous startup was a company called Jungle Disk. They were purchased by Rackspace. As part of that, he was the storage architect for Rackspace to bring cloud storage to market within Rackspace. And he went out and evaluated a lot of the storage platforms that were out there, and he had a very different set of criteria of he wanted storage that was very scalable, that is, if you're going to do workload consolidation, or if you're going to do multiple tenants or multiple areas within an organization, they may not necessarily know what each other is doing at any given time. So how do you guarantee multiple folks will be able to consolidate that storage and then work together as opposed to stepping on each other within storage? And it was an environment and an architecture that didn't exist previously. And so because of that, he went and really created that. And he created with these principles in mind. He saw public cloud really changing the market. And there's a lot of buzzwords out there. You know, you can call it software-defined data center. You can call it third platform. You can call it private cloud. But at the end of the day, it's next generation data center. How do you create a storage environment that is agile, that is scalable, that has automation, and it is predictable if you don't know the workloads that are on it? Not just one or two departments or tenants. What if you have hundreds to thousands of applications? How are you going to manage that if it's just a console with a storage administrator? And so what has to happen is how you think about storage management has to change. And it has to become very simple and simplistic in its management, but at the same time more complex in its ability to isolate and protect. And if you combine that with where storage is going as an industry, because really what's happening is data center storage really has remained fundamentally unchanged, if you will, for quite a while now. But at the same time, the market is shifting. And so we're moving from an area where we're looking at things in an old way and managing things in an old way, but the market is moving from a product perspective. We are moving into a disk to flash environment. The cost economics of flash are constantly at the point where they are getting more and more economical. We're getting economies of scale out of flash, and it is becoming much more pervasive in the market. And there's a lot of outside pressures from a business, from outside customers, to how do we move from siloed infrastructure, from islands of storage, if you will, to a shared economics model, a shared infrastructure model, a workload consolidation initiative. And so if you combine those two together, you will actually find that where SolidFire fits in a portfolio actually directly aligns with where the market was going, both from outside pressures and from where the product is moving in the market. And because of that, that brings me to the next point. Where does SolidFire fit? As some may or may not know, SolidFire was purchased by Netapp. The acquisition was announced in December of last year and was closed in February. So I've been with SolidFire a little over 2 years now, but I have become a Netapp employee as of February of this year. And we are learning what it's like to go from a single model world, if you will, to a portfolio model. And Netapp is learning this as well. We're going on this journey together. And it's really interesting if you really sit down and look at an all-flash portfolio at Netapp. It is the broadest all-flash portfolio in the industry. And the products are complementary. If I look and start on the left-hand side, we have the EF, the Netapp EF portfolio. It is really designed for speed. It is designed for standalone apps. Let's say you have a very large database that just needs to go fast, and you need very low latency and really kind of a direct attach model, if you will. Then EF is going to be a fit. If you really want data services at its core, AFF, or all-flash FAS, is really this kind of middle of the road virtual infrastructure. You have lots of data services, lots of software to support where you're going. And also, by the way, that's why I was asking that protocol question earlier, unified multi-protocol storage. And if I go to SolidFire on the right, SolidFire is a slightly different paradigm in that you're looking at scale and you're going back to that origins of the company. What is cloud-like infrastructure? Service providers or enterprises or organizations that want to act like service providers, that are facing pressures to consolidate down. How do we do that and offer performance control in true multi-tenant environments and guarantee that performance and that quality of service to again, hundreds to potentially thousands of applications at any given time? And so if I look at that, that's kind of divided up into 3 columns. But if I go to this slide, this really encompasses the entire all-flash portfolio at Netapp. You have Netapp Data Fabric really as the overarching management umbrella at the bottom and the vision. And then if I go, I'm actually going to go on the right side where it's high performance and work my way to the left and take everyone through this here. If you want extreme performance, there is where this all-flash industry started. Flash V1, right? This is PCI Flash. This is first generation Flash companies where it was really more of a point solution than all-purpose and scale out and scale up capacity. You were solving very unique issues. And then we move over to the EF series, again going back to their kind of strengths and where they would fit in this kind of bell curve. And this is very much, this curve is designed intentionally in the fact that if you look at the middle of it, the performance and capacity section, this is those folks that want to do as a service and consolidation initiatives. But at the same time, you'll notice there is both SolidFire and Allflash FAS in there. So where do you differentiate it? Again, you differentiate on scale and guaranteed performance or data services. And then on the low end of the curve, as kind of the curve tapers off to the other end, we have other objects in the Netapp, or other products in the Netapp portfolio, in that you have Storage Grid, you have AltaVault. So you have this idea of, on the one end, storing things and vaulting things, and on the other end, going super, super fast. But as you can see, a very complete and diverse portfolio for Netapp. And with that, I'm going to move on to another poll here quickly. And this is designed to be a little, again, it's almost, we don't want everyone to write too much here, so there's a limit on the characters here, but what are your performance requirements? And what happens if you fail to meet those performance requirements, right? Everyone has different, I guess you could say, levels of pain, right? And what we're looking at here, and I certainly have some stories. So I'm an ex-data center operations person, and I managed a decently large data center for a number of years, and sometimes it's application dependent, sometimes it's account dependent. And so what we're really looking for here is a little bit of share your experiences and what is going on and where are the pain points, or again, areas for optimization within your accounts. I'm going to give that just a couple more seconds. All right. Thank you very much. All right. And with that, I'm going to move on to the next one. So I'm going to specifically talk the rest of the time about the all-flash space and specifically where SolidFire fits and use cases. The reason being, the use cases are very important at SolidFire. the types of applications and workloads are really where we want to focus. Because again, if you're consolidating a bunch of things, you need to simplify the operations. And we want to really be the best for many different tiers of applications, if you will. And so I'm going to take you to this. Gartner does the All-Flash Array Magic Quadrant. And in addition to the standard Magic Quadrant, they do what they call the Critical Capability Study. And think of the critical capability study as a just feature to feature and fit to an application shootout of all of the arrays that are out there and that are considered on a year-by-year basis. And for 2 years in a row, and that is as long as this Magic Quadrant has existed, SolidFire has been the highest rated all-flash array in critical capabilities and has scored either #1 or #2 in all of our what we consider kind of bread and butter use cases, if you will. This is where we like to focus. This is where we feel confident that if you have these kinds of environments, that SolidFire will be a good fit. And we're asking you, not just to take our word for it, but to take Gartner's word for it and the research they've conducted around this. And this isn't just a 1 year kind of thing. This is 2 years running that we are considered, when it comes to the actual capabilities of storage, the highest ranking one in the market. And with that, I'm going to also say, in addition to the Gartner thing, what are our customers saying to us? What does a next generation data center look like, and what are the use cases that are typically deployed? I noticed in the applications earlier, DevOps there in particular scored very high. Private cloud, workload consolidation, DevOps, managed hosting, whether that's internal managed hosting or external managed hosting. These are all areas that play specifically into the strengths of a SolidFire system. This ability to be agile, this ability to be dynamic. And the way I like to think of it is SolidFire use cases actually line up very well to the concept of sometimes what we would call cloud computing. But I'm actually going to turn that on its side a little bit, because I don't necessarily feel like cloud computing was ever at times an appropriate word to define this. I like to say just dynamic pools. What is it when we're talking about a lot of these use cases? We're talking about dynamic pools. Dynamic pools of compute, dynamic pools of network capacity, dynamic pools of memory, and dynamic pools of storage. You can't have a next generation data center in which these use cases are dynamic and the pools of your resources are, and your storage still be static. And so because of that, this is where we start to see the SolidFire architecture specifically match next generation use cases, and that was done intentionally. And by the way, I just wanted to pause here and say, as folks have questions, as anything comes up, please just pop the questions into chat. And what we will do is we will answer some of them either in chat ongoing, or we will take time at the end and kind of answer them live as well. So whenever you have a thought about it, please pop it into the chat, and either somebody will answer immediately, or we'll take some time here at the end to answer them live on as we're talking. Now, I keep talking about simplicity. This is what I would consider, and I'm an again, data center admin, storage admin. I did a lot of these in my day. What are some of the tasks that I have to manage, or some of the things I have to look at and do if I'm going to manage storage in a multi-application environment? Well, there is lots of sizing that typically has to happen. There's lots of care and feeding. There's lots of looking at the layouts and potentially rebalancing workloads. There is, kind of the first generation of this, if you will, was tiering of storage. How do I move things from flash to disk and vice versa? But there's always been This has been a heavy lift initially, and it was kind of pushed back on the storage administrator. That was the first generation. The second generation of that was you're starting to see automation, but that automation a lot of times was after the fact. And so what we actually would see is something happens on a storage array, and we would have to do something. Let's say you get a hotspot. Well, you get a spike or a hotspot, it gets kind of flagged for tiering and gets moved typically sometime later after that hotspot dissipates, because moving a hotspot on top of a hotspot could further worsen the problem at times. And so you move things, but you move things after the fact, and you're always kind of chasing, hoping it will reoccur. But if you have a spiky workload or multiple workloads that spike at different times, you're always one step behind. And so because of that, this is what storage system tasks look like in a SolidFire world. We have removed a lot of the administrative burden away from the storage administrator. The reason being, we want to really move the storage administration GUI, if you will, directly into the applications that matter. If you're running VMware, we want to provide the virtualization administrator the ability to do storage tasks. We want, if you're doing automation, if you're doing PowerShell or Puppet, or you're doing it in a private cloud in OpenStack, how do you enable your application stacks to be able to take advantage of dynamic storage, again, making everything dynamic pools? Well, in order to do that, you have to simplify this, but at the same time, manage it all on the back end. And that's what we've done. We've basically taken this storage and really removed a lot of those headaches and put them on the backside and put it on SolidFire to dynamically move things around to make sure we guarantee performance. And so with that, what I'd like to do is go into SolidFire for a little bit. So what is SolidFire? Well, let me start with what, at its simplest form, Scaleout Storage. What does Scaleout Storage mean? Scaleout Storage means taking platform building blocks. And what I've done here is I've listed the models we currently have out on the market. And how do you take a number of those building blocks and build them on top of each other and create that kind of dynamic storage pools that we keep talking about? And in addition to that, so you notice there's not necessarily a lot of models there, but in addition to that, it's an all-inclusive feature set on top of it. This isn't a bunch of license keys for every little feature. Encryption at rest included on the box. It's simply an option that we would turn on. Snapshots and clones included. Replication, both synchronous and asynchronous, included. Integrated cloud backup included. Multi-protocol support. Now I will say this though, I want to stop and pause there and be very clear, especially those that are familiar with a Netapp AFF world. This is block storage. So this is fiber channel and iSCSI block storage. We do not do CIFS or NFS sharing today, and so I want to be clear there. But secure multi-tenancy as well. If you're going to do workload consolidations, you need to be able to provide that in an isolated and secure environment. We also offer a cloud-based monitoring service as well to allow you to do kind of capacity planning. We have ongoing logging. All of this is provided, again, at no additional cost. In addition, one of the very common concerns that we got, especially, and this is Allflash as an industry, not just SolidFire, but as a new storage medium comes online, until it is proven out and until the appropriate architectures kind of evolve and bubble up, there are concerns. One of the concerns about the first generation of Flash architectures was this idea of it's going to be obsolete. how am I going to protect a large investment? How am I going to protect myself from forklift upgrades? And also, since this is all flash typically has a number of, we call it wear cycles, right? How many times can you actually write to it? And so what is the flash endurance? And do I have to worry about that? Am I going to have a storage array that I can only write to so many times and then I can't write to those drives anymore? And so, first of all, let me just say we've solved all of those problems. With our architecture, you're not doing forklift upgrades anymore. You're not doing data migration anymore. And so, in addition to that, we're also skipping wear leveling, if you will, right? We are basically writing to the storage in such a way that wear leveling just kind of comes up and moves on. And so with that, how do you put these together? Well, it's a scale-out architecture. And what happens here is we just kind of add nodes as we go. And so we start with a minimum of 4 nodes. And then we can expand this. We dynamically expand this, both kind of linear and nonlinear, if you will. You can mix and match capacity and performance. And so I add another one. And both the performance and capacity of the array increase. And I add another one. And so on. Well, in addition to that, what if you want to go down? What if you want to remove one? We allow that as well. Very unique differentiator in the fact that it not just allows us to go down for the sake of going down, but it brings up some very interesting use cases. Number one, what if you have multiple arrays? You have this idea of multiple malleable storage, right? You can have multiple arrays, and if I have too much capacity in one and not enough in another, I remove a node from one and put it in another. We have multiple customers that we call it FedEx load balancing. They'll take a node, put it in a FedEx box, ship it to another location, put it in. How do you handle the next generation of nodes that comes out? You insert a new node in, you take an old node out. You're not having to do forklift upgrades ever again. You're not having to do storage migrations ever again. So scale out agility also helps with your operations and does some very interesting things that really honestly haven't been done in this industry to date. And in addition to that, we create both a pool, again, going back to the pool concept, and most folks in the industry will pool capacity. We pool performance as well. So in our dashboard, you will see how much performance we're using on the box. And you'll see a graph of how much a node and how much a volume or a LUN is being utilized. And that you will see it dynamically changing over time. If you were to add a node or remove a node, it simply updates those large pools of capacity. So think of this as one large pool you can dip into at any given time. But having a large pool has a downside. If you have a very large pool, what happens if folks step on each other? Probably one of the worst use cases we could think of is you have a high-performance database, and you notice there's a box on the left there. And in this idea, we give all of our applications a minimum amount of IOPS and a maximum amount of IOPS. So we give it basically a window of performance that we want to assign to that. A high production database, giving it 100 IOPS at a minimum, the guarantee is probably not a good idea, especially if it is a business-critical application. And what if you are actually consolidating a bunch of resources on here, and I don't know, let's say we put VDI on there. A classic case is VDI boot storms. So you have a number of volumes of VDI. They all try and boot at the same time. You have a database that you haven't necessarily guaranteed against, and this is a very typical scenario in a lot of storage applications. How do you prevent that? Well, up until now, a lot of folks have put a cap on things as opposed to a minimum guarantee, or this is how islands of storage develop. The only way to guarantee it is to put it on its own storage. And because of that, so how do we fix that? Well, you'll notice in that checkbox there, I've changed this database to 15,000 IOPS at a minimum. And you'll notice there on the right-hand side where it says Bootstorm, my throughput has gone down dramatically on the overall performance of the system. The reason being is this database is still getting the capacity it needs, while at the same time allowing to account for this VDI Bootstorm. And this isn't just one example. This is, this could be happening concurrently all over the box at any given time. And we don't necessarily know at any given time who's going to spike when. And the best analogy I have of this is, think of this as a utility grid. If you are a power company, how do you manage power requirements to, let's just say a neighborhood of homes? Well, they do it by estimations, both of current load and predictive analysis, and we do kind of the exact same thing. We take those volume characteristics from a performance standpoint and we monitor them in real time, and we do look-ahead predictive analysis. And we basically handle this like a power grid. We want more applications on the box at any given time, because the more things that are on there, the more things we can balance against. And so it's this utility grid consumption model that is actually built into the very core of what we are. This isn't a bolt-on feature that was added later on. This was built at the very heart of what SolidFire is trying to achieve in the industry. But if I kind of do this natural progression, I've done scale out. That allows me to do decently large storage, allows me to do a storage pool, allows me a central place to manage everything. Well, then I had to guarantee performance. Okay, now I've guaranteed performance. Well, the next step, kind of problem we have to solve is automation. Because again, if you're doing hundreds to thousands of applications on a box, how are you going to manage that, right? And so there's this idea of a self-service portal, moving into VMware, moving into OpenStack, moving into, for those shops that want to do it, moving it into an SDK. I mentioned earlier we have Python, we have Java, we have PowerShell, we have Puppet modules. We're basically trying to figure out how to do completely programmable storage. And how do we do dynamic storage? Because again, going back to my previous example of that database that needed more performance, what I think is going on is people sometimes think, well, it's set it and forget it. And a lot of these things are just, I'm going to set them this way and this is the way they always need to be. That's actually not true. When I have completely programmable storage, I'm actually able to do dynamic calls. And so if I see a problem in the storage, I can fix it. We also have customers that for different use cases will actually do different quality of service and performance guarantees on the systems at different times of the day. For instance, running production all out during the day, but then maybe backing production down somewhat after that, so that maybe I can do, again, I can turn on backup windows and I can turn that up to very high quality, or basically kind of open up that faucet, if you will, to provide them with more performance as we do backups in the evenings. Turn that back down. And so I'm able to dynamically change this environment based off of the needs of applications, but also sometimes given times of day or times of month if we're doing batch processing or other things like that. So I'm able to handle peak workloads intelligently and get in front of them. Workloads become a proactive event versus a reactive event. And with that, I'm going to give this is the last poll, and then we're going to open up for questions. So if you don't mind, everyone, respond to this poll, but also at the same time, please consider the next step is questions. So any questions you have, go ahead and put those in chat. We have some that we've kind of received privately here as well, but feel free to send them to us privately or kind of to the broadcast of the All Chat as well. And we'll certainly take those and we'll handle some questions here. All right, everyone. Thank you very much for your responses there. And let's open it up to questions. I think we have some questions already queued up. We've had some questions kind of coming in, and we have some folks kind of lining them all up. And so what is our first question today?
Hey, Aaron, Brian here. We had quite a few questions in regards to data at rest encryption, but you addressed that earlier on the call. But just to reiterate that it's an all-inclusive feature set and that comes native. But the other one we got a couple times was, is our systems for DoD use been approved with common criteria certification?
Yep, fantastic question. And so the short answer is yes, but let me give it just a teeny bit of background as well. Yes, we are common criteria certified. We're certified at EAL2, and on our current operating system, we actually call it Element OS, by the way, but Element OS version 8, which is our current operating system. So we have achieved that, and certainly if we want as a follow-up, we can provide a link to all of that information as well.
Aaron, I got a question regarding compression and deduplication. Can it be turned off, and is it always on? And is it the same as the compression and deduplication that the FAS has?
Yeah, fantastic question. So multiple answers there, and I'll kind of take them all in turn. So first of all, there is the need for compression and deduplication in an all-flash space. Anytime you deal with all-flash storage, in order to get efficient storage, meaning that the cost of the flash itself, even though that price is coming down, it is really considered table stakes to do compression and deduplication, and quite frankly to do both, to be as efficient as you possibly can. So yes, we do compression and deduplication on the storage. Yes, it is turned on and actually cannot be turned off, and it is in line in our systems. And so, folks will say, do you get a performance hit, or is there any, scenarios in which you don't? The short answer is no. It is always there, and our systems are built around it, and all of the specifications we publish are with it kind of turned on, going full bore all the time. Is it the same as what we're doing in all-flash FAS? The answer is no. Everyone does it slightly differently. But at the end of the day, I think we have reached a point where the approaches are very similar and the approaches are very necessary for all flash. And
Aaron, maybe just a quick second to clarify. We got a little bit of confusion on driveware and when we talked about our flash forward guarantee. If you could maybe touch on that just slightly more.
Yeah, absolutely. So think of it this way. And this one will be a slightly longer answer, so I apologize. But think of it this way. When you're writing to SSDs or all flash, you only have so many writes, so you want that to be as efficient as you possibly can. So it almost goes into the previous answer of deduplication and compression. You want to write as little as possible. And also what we do is as writes come in, we will compare them to a global lookup table, and we will do deduplication on the fly. Basically, have we written this block anywhere in the all-flash? And if we have, it's global deduplication. So again, the bigger it is, the more data you have, the more deduplication you will get. But what happens is you're as efficient as you possibly can. So what we're trying to do is prevent as many writes as possible from ever even hitting the drives to begin with. But you have a certain amount of writes that will happen over time. But what we do is we do a lot of, like we have an NVRAM card, so if they're doing a bunch of what we call write amplification, writes over and over, it actually gets handled in the NVRAM card before it'll ever hit the flash. And then if we run into a case where we do start to show what we would consider excessive or abnormal wear, we will go ahead and proactively replace that drive, no questions asked, no matter what scenario it is, for the life of the storage. What other questions do we have? Go ahead.
I got a question regarding just maintenance related, like how difficult is it to service a node, say a node fails? Do you have to crack open the box, or, I mean,
yeah.
how do you fix the
Fantastic
node?
question. Yep. And again, the theme here today has kind of been simplicity, if you will. We have it down to a very minimum number of field serviceable parts, and we've designed that on purpose. So we want everyone to certainly be up and running as fast as possible. Now, I will say again, before I answer the question, in the event of a scenario, think of as, if a node were to fail, remember, go to that Scaleout architecture. If you fail a node, we treat it just like scaling down. And so for us, failing a node isn't necessarily what some folks, others would consider a super high-profile event, because all we're doing is, in our instance, is removing a node. But in the event that a node actually has to be serviced, we have it down to just a bare minimum number of parts. You can replace the power supply, you can replace one of the SSDs or Allflash in there, and you can replace the node itself. So again, trying to keep troubleshooting down to a minimum and really removing that pain from the customer and simplifying the operations as much as possible. We probably have time for maybe one more, and then we'll go ahead and wrap it up. Do we have any more?
I think the only one that was kind of left untouched that was somewhat answered in the automation realm, but getting more specific into PowerShell integrations. People want to hear about that a little bit more.
Yep, we get a lot of questions around PowerShell in particular. The PowerShell automation, and just real briefly, we do have a PowerShell kit, if you will, and folks will immediately want to know, well, how much of your API, if you can really completely manage the story from API, how much of that API is covered in the PowerShell module? The PowerShell module is actually very close to 100%, if not 100% with the latest release. We just did another release of it last week or 2 weeks ago, and I want to say we're 100%, but if not, we're high 90% coverage in our API because we have seen really great traction in the market from that. And with that, I think that really kind of covers it today. I don't see any more questions kind of coming in right now. So I wanted to thank everyone again for your time today. And what I'll do is I'm going to go ahead and put on this last page here. These are some common resources. Again, solidfire.com, of course. Developer.solidfire.com for our developer community. Very active YouTube channel when we go out and say, okay, what is it like to actually add a node or remove a node or some of these other technologies we talked about today. All well documented out there. And also Chris's information as follow-up as well. What's that?
The correction on the phone number.
Oh, okay. So Chris actually said correction on the phone number because, yeah, there's too many digits there. Sorry about that. We'll get it corrected in the slides that we send out to everyone. Sorry about that. And with that, Phyllis, would you mind closing us out for the day?
Ladies and gentlemen, that does conclude the webinar for today. We thank you for your participation and ask that you please disconnect your line.